Welcome, ladies and gentlemen. Today we're going to talk about solving exponential equations, day 2. Today we're going to deal with the topic of what happens if the equation is already in log form. So, in order to do that, you're going to need a calculator, a pen and or pencil, and, of course, most importantly, your notes. Let's get started. There are two types of log equations, so very similar to what we've already done. You can have logs on both sides, or you can just have log on one side. Now, this is your example for what things are going to look like if you have logs on both sides. So we're going to be making things equal. If these are the same, our log and our base are the same, then we can set these equations equal to each other. So we're going to say 4x minus 7 equals x plus 5. Now to solve this, I'm going to subtract x on both sides. And I'm going to get 3x minus 7 equals 5. Add 7 to both sides. 3x equals 12. To finish this one off, we're going to divide both sides by 3. And x equals 4. Now, just like our last ones, you guys, you can plug the 4 in for x here and here to make sure that you have the correct answer. I'm not going to make you do it, but it's a really good idea for test or quizzes. All right, moving on. Now, this is what it's going to look like if we have a log just on one side. Our goal here, ladies and gentlemen, very, very important. We need to isolate the log, okay? And then we're going to change it into exponential form. So first thing we have to do is get our log by itself. All of this right here is our log. So we have to get rid of the 7 out in front. In order for us to do that, we're going to subtract 7 from both sides. So I'm going to get log base 10 of x equals negative 3. Now once I have this by itself, I'm going to rewrite it in exponential form. Here, start with my base. Here's my base number, so I have 10. My exponent's always by itself to the negative 3 equals x. Well, 10 to the negative 3, you can have two answers. If you write it as a fraction, it's going to come out as 1 over 1,000 equals x. Or if you have it as a decimal, it'll be 0.001 equals x. I am fine with either answer. Now, once again, ladies and gentlemen, we can plug this back in for x to make sure that we got the correct answer. All right, moving on to our next example. We have to solve this one. So first thing we have to do, isolate our log, in this case ln. So here's our log. To get this by itself, we have to get rid of this 3. So I'm going to add 3 to both sides. I get 2 ln of x equals 8. Now to get ln all by itself, we're going to divide both sides by 2. ln of x equals 4. Now once I get my ln all by itself, I need to rewrite in exponential form. So my base, remember, whenever I'm using ln, my base is e. So I have e to the 4th power equals x. I'm just going to type this into my calculator. So e to the 4th power is approximately 5.46. There's my answer. And remember, ladies and gentlemen, if we want to check, we can to make sure we get it 100% correct. All right, here, ladies and gentlemen, our log is actually all by itself because this 3x is part of the log. So now from here, we're going to go straight in to exponential form. So I have my base is 3, my exponent is 2, and it equals 3x. Well, 3 squared is 9. So I get 9 equals 3x. To get x by itself, I'm going to divide both sides by 3. So 3 equals x. There's my answer. And if I wanted to, I could go in, plug it in for x, and check to make sure I have the correct answer. All right, this is the same idea, ladies and gentlemen. Since this part here is in parentheses, my log base 2 times the quantity x minus 6 equals 5, This is in parentheses, so my log is all by itself. So once again, we're going to go straight into exponential form. So I have 2 to the 5th power equals x minus 6, and 2 to the 5th power is 32 equals x minus 6. To get x all by itself, we'll add 6 to both sides. So 38 equals x. There we go. Now off to our last example. Here it is. I have log base 4 of x plus log base 4 of x plus 12 equals 3. First thing, ladies and gentlemen, that I have to do for this one is I have to condense it. I can only have one log if they're on one side. So in order to do that, I'm working with addition. And addition turns into multiplication. So I'm going to have log base 4 of x times x plus 12 equals 3. Well, now I know I can multiply this through, so I can distribute this. So I have log base 4 of x squared plus 12x equals 3. Now that I have my x by itself, because this is all together, I can rewrite it in exponential form. So my base number here is 4. My exponent is 3, and it's going to equal x squared plus 12x. Now, 4 to the 3rd power is 64, so I get 64 equals x squared plus 12x. Now, we have a bit of a problem here because I have x squared and x. So yes, ladies and gentlemen, we will be factoring once again. We're going to subtract 64 on this side, and when I do this, I'm going to get 0 equals x squared plus 12x minus 64. So from here, I need to do the AC method. So here we go. AC method. A times C has to add up to B. So my A is 1 and my C is negative 64. So I need to find the factors of negative 64 that add up to 12. So my factors of this are going to be negative 4 and 16. Once I know that, I can plug it back in. So I have x squared minus 4x plus 16x minus 64. And I'm going to plug it into my box. So I have x squared minus 4x, 16x, negative 64. We're going to take the greatest common factor here. So I have negative 4x. Here I'm going to get x. Here, oops, sorry, this one should be 16. Sorry, ladies and gentlemen. 16. This one over here is negative 4. So I have two equations here. I have x minus 4 equals 0, so x equals 4. And I have x plus 16 equals 0, so x equals negative 16. Now, since I have two answers, ladies and gentlemen, there's a chance that I could have an extraneous solution, so I have to check this one. Whenever we get two answers, you have to check it. So when I check negative 16 and 4, I'm going to plug it in to my condensed form. So I'm going to plug it into this equation right here. So I have, for negative 16, I plug that in, and I'm going to get log 4 of negative 16 squared plus 12 times negative 16 equals 3. From there, I'm going to get log 4. If I plug this in, I get 256 minus 192 equals 3. Log 4 of 64 equals 3. Here, I have to do change of base. So I'm going to have log 64 over log 4 equals 3. When I type this into my calculator, I do indeed get 3 equals 3. So 16 is a solution. Now I'm going to do the exact same thing over here for 4. So I'm going to plug it into my same equation. I have log base 4 of 4 squared plus 12 times 4 equals 3. So log base 4 of 16 plus 48 equals 3. Log base 4 of 64 equals 3. Do my change of base. So I get log 64 over log 4 equals 3. I type that in my calculator, and 3 does indeed equal 3. So both of these in this case are solutions, but we have to check because sometimes we can have extraneous solutions because they don't work. All right, that is all I have for you amazing, wonderful people. So I hope you have a wonderful, fabulous day, and I will be seeing you later. Bye.